future of energy. How space-based solar power could change the world. Imagine a world where clean energy is available 24 hours a day, 7 days a week, regardless of weather conditions, cloud cover, or the time of day. It sounds like science fiction, but it may soon become reality. Today we're exploring one of the most ambitious energy concepts ever proposed, space-based solar power, and how innovative companies like Starcatcher are helping turn this futuristic vision into something tangible. To understand why this technology is so exciting, we first need to look at one of the biggest limitations of renewable energy on Earth. Solar power is one of the fastest growing energy sources in the world. It's clean, abundant, and becoming increasingly affordable. However, traditional solar panels only generate electricity when the sun is shining. At night, energy production stops. During cloudy weather, output can drop significantly. This creates a challenge for power grids that require a consistent and reliable supply of electricity. Now imagine placing solar panels in space. Unlike solar panels on Earth, solar collectors in orbit can receive sunlight almost continuously. There are no clouds, no atmospheric interference, and no nighttime cycle. In certain orbits, solar arrays can collect solar energy more than 99% of the time. This means they could generate far more electricity than equivalent solar farms on Earth, but collecting energy in space is only part of the equation. The real breakthrough is transmitting that energy back where it's needed. The concept works by converting the collected solar energy into a form that can travel long distances, typically microwaves or laser beams. These energy beams are then directed toward receiving stations on Earth, known as rectennas. The rectennas convert the transmitted energy back into electricity, which can then be fed directly into the power grid. Think of it as wireless power transmission on a global scale. Instead of generating electricity in one location and moving it through thousands of miles of transmission lines, energy could potentially be harvested in orbit and delivered directly to where it is needed. This is where companies like Starcatcher enter the picture. Starcatcher is focused on developing technology that could allow energy to be transmitted through space itself, rather than every satellite carrying large amounts of power generation equipment. Future spacecraft could receive energy remotely from dedicated power sources. It's a concept that could transform the economics of space operations. Today, satellites are limited by how much power they can generate and store. If energy could be delivered wirelessly in orbit, satellites could become lighter, more capable, and operate for longer periods without requiring massive solar arrays. This could support everything from communications and Earth observation to scientific research and deep space exploration, but the implications don't stop in space. If large-scale space-based solar power becomes commercially viable, the impact on Earth could be enormous. One of the biggest advantages would be energy reliability. Unlike wind and conventional solar energy, power collected in space could be available around the clock. This would reduce the need for large-scale battery storage and help stabilize renewable energy grids. Another potential benefit is global energy access. Remote regions that currently struggle with reliable electricity could theoretically receive power without the need for extensive infrastructure. Areas affected by natural disasters could also benefit from rapidly deployable receiving stations capable of receiving energy from orbit. The environmental benefits could also be significant. As countries around the world work to reduce carbon emissions, access to continuous clean energy could help accelerate the transition away from fossil fuels. Of course, there are still major challenges ahead. Launching large structures into space remains expensive. Building orbital solar power stations would require advanced robotics, autonomous assembly systems, and highly efficient power transmission technologies. Engineers must also ensure that energy beams can be transmitted safely and accurately over vast distances. Then there's the question of economics. The technology must become affordable enough to compete with existing energy sources. While costs are falling rapidly in the space industry, large-scale deployment will still require substantial investment and technological progress. Despite these challenges, momentum is growing. Governments, research institutions, and private companies are investing billions into next-generation space technologies. What once seemed impossible is increasingly being viewed as a realistic long-term solution for the world's energy needs. History has shown that revolutionary technologies often begin as ambitious ideas. Flight was once considered impossible. Landing humans on the moon seemed unrealistic. The internet was once a niche experiment. Today, space-based solar power may be following a similar path. Whether it takes 10 years, 20 years, or even longer, the idea of harvesting limitless solar energy in space and transmitting it wherever it is needed could fundamentally change how humanity powers its future. The sun provides more energy in a single hour than the world consumes in an entire year. The challenge has never been finding enough energy. The challenge has always been capturing it. And perhaps the answer has been waiting above our heads all along. If you enjoyed this video, don't forget to like, subscribe, and let me know in the comments. Would you trust electricity beamed to Earth from space? Thanks for watching, and I'll see you in the next video.